You know how everyone says cybersecurity is important, but no one really shows you how to start learning it. I've been there, Googling for hours, wondering what to build or how anything actually works. That's why, in this video, I'm going to walk you through 3 beginner-friendly cybersecurity projects you can build with Python. In this video, I'm going to cover a password strength checker, a port scanner used in network reconnaissance, and a hash cracker that shows how weak passwords get exposed. And you know the best part? I'll explain every single line of code so you actually understand what you're building and why it matters. So if you've ever wanted to learn ethical hacking, strengthen your coding game, or kickstart a cybersecurity career, this is your video. Alright, so here's the password strength checker. Let me run through the code line by line, and then I'll run the code and see how it works. In the first line, we're importing regex, which is basically checking for regular expressions. Next, in the second line, we define a function called checkStrength, which takes the password which comes from the user as input. And in that function, we define a variable score, which is initialized to 0 at first. This score variable will basically keep track of what the password actually includes, and in the end it would actually check how much the score is to give a rating. In line 4, it is checking if the password length is greater than 8. This is a very common requirement for passwords, and it adds 1 to the score if the password is of length greater than or equal to 8. In line 6, we're checking if the password contains any uppercase alphabet. If it does contain an uppercase alphabet, we add 1 to the score. In line 8, we're checking if the password contains any lowercase letters, and if it does contain that, we add 1 to the score. In line 10, we're checking for any digits, which is basically from 0 to 9. If it does contain any digits, we add 1 to the score. Lastly, in line 12, we're checking if the password contains any special characters. If it does contain a special character, we add 1 to the score. In line 15, we're basically just checking what the score is and giving it a rating based on that. If the score is very low, which is basically 0, it would be very weak. Or if the score is greater than 5, we'll give it an excellent rating. In line 17, we're getting the password from the user through the command prompt. And then in line 18, we're basically calling the function checkStrength and passing password as the parameter in it. Now let me show you how this code runs by giving you a live example. Now after we run the code, we see that it prompts the user to enter your password. In this case, I'm just going to keep it empty and hit enter. So it says the password strength is very weak. This is due to the fact that there's nothing in the password, so the score is 0. Next, let me run it again. Let me try using the word just hello. It gives us weak because in this situation, we only have lowercase letters and the password length is less than 8, so we just get 1 point. Now, let me run it again and give you a better example. Let's do hello 1 2 3. Now this should give us very strong. This is due to the fact that it has 8 characters. It has an uppercase, it has a lowercase, as well as a digit. That's why we get very strong. Now let me just modify that and change it to hello 1 2 3 with a special character. This should give us excellent because it contains all the parameters that we've mentioned over here, and it gets a score of greater than 5, which is basically excellent. Alright, so the next piece of code that we're going to look at is a port scanner. A port scanner basically just scans the ports and is very important in a cybersecurity aspect due to the fact that this lets us know that what ports are open and what ports are closed. Other threat actors can use this information to attack open ports that are not being used. Therefore, it is important to keep a check on the open and closed ports. On line 1, we're importing socket, which is basically just a socket library which lets us create network connections. In line 3, we're prompting the user to input an IP address to scan. In line 4, we're mentioning a few common port numbers, and if you are not familiar with this, port 21 is for FTP, 22 is for SSH, 23 is for Telnet, 80 is for HTTP, 443 is for HTTPS, and 8080 is for any alternative HTTP. In line 6, we're just printing the fact that we're scanning a particular target port. In line 8, we're creating a for loop that loops through all of the port numbers. In line 9, we're basically just looping through each port in the list. AFINet basically stands for IPv4, and sock stream indicates a TCP connection. In line 10, we're setting the timeout to 1 second because we don't want to wait on dead ports. In line 11, we're trying to connect to each of these ports, and we're storing the result of this into the variable result. If the result is equal to 0, then the port is open. If it is anything but 0, then the port is closed. Now, let me try running this code. Okay, now that we've run it, prompts us to enter an IP address. In this situation, what we're going to do is use a loopback IP address, which basically checks the IP of your own machine. It is 127.0.0.1. Once we hit enter, it's going to be scanning the port. And now we can see that all of these ports are closed. To check if our code is working correctly, I have this piece of code over here that basically starts or opens port 8080. So let me run that. Now this HTTP is running on port 8080. So if we run the code once again, we will see that once it reaches 8080, it should say that port 8080 is open, just because of the fact that we have something running on this port. Alright, lastly, we're going to be talking about the hash cracker. In this, we're basically trying to reverse engineer the hash to find the actual password of the user. This is done by using 3 different files. We have the actual file that has the code. We have a wordlist.txt, which contains a few sample passwords that I've created. You could use any other passwords that you want. Basically, hackers would have a list of common passwords, and they would try to create hashes of each of these words and try to reverse engineer it into finding the actual password. In the third file, called hasher.py, we have a small line of code that basically encodes hello 123 using the SHA-256 to create an actual hash of this password. Let me run you through the code and then give you a demo on how this actually works. In line 1, we're importing the hashlib module. This allows us to use the hash functions like the SHA-256 or MD5. We're going to use it to hash each word from the list and compare it to the input hash. Next, in line 3 and 4, we're prompting the user to input the SHA-256 hash as well as the path to the list of the word, which basically contains all the passwords. In line 6, it starts with a try block, which will catch a file related error if the word list doesn't exist. The with open line opens the word list file in read mode, which is depicted by the R, and assigns it to the variable file. This for loop loops through each line in the file. The words are stripped, which basically gets rid of the empty spaces or any new lines. This is the core comparison. The word.encode turns the password into bytes, which is needed for hashing. Then the hashlib SHA-256 basically hashes the word using the SHA-256 and gives us the result in hexadecimal form. Then it checks if the result matches the input hash. If a match is found, we print password found and the actual password and break from the loop. If it isn't found, then we prompt the user that password not found in word list and then exit the loop. The last 2 lines basically are just some error handling that if the file is not found or could not open it, then we just prompt the user that the word list file is not found. Now let me give you a breakdown and run through the code and show you how it actually works. First, we're gonna encode and create a hash of the password hello123. After we have this hash, we're going to go to the actual file and run this script. Now it prompts us to enter the SHA-256 hash, which is basically what we just created. So I'm going to copy this, paste it into here, hit enter, and then enter the path to the word list. So in this case, it's just wordlist.txt. Make sure that this file is in the same directory as the actual script file. So let me just type wordlist.txt and hit enter. Now, what this basically did was checked the hash and reverse engineered it to actually find the password from the text file. Let me try this with another password. Let me copy let me in and then paste it over here. Now let me save this file and run it again. In this case, as we can see, the hash is totally different as compared to the one before. So now let me run this file again and see if it works. So we're just gonna paste the hash over here, hit enter, enter the text file name, and then hit enter. And in this case, as you can see, it has given us the actual password from the hash of the password. This is very useful as hackers can reverse engineer and find the actual password using the hash. And there you have it. 3 awesome beginner cybersecurity projects in Python. In this video, you learned how to evaluate password strength, scan for open ports on a device, and crack the SHA-256 hashes using a word list. If you enjoyed this breakdown, give this video a like, subscribe for more hands-on content, and let me know in the comments which project you'd like me to build next. Thanks for watching, and as always, stay curious and stay safe out there. Peace out.